Hello everybody, welcome back to another video, and today this is the advanced part of the Scratch collection game for Science Olympiad. Now, this is a script that I did not make. This is this script from Patch Tutor. He said it's fine to share it. Of course, I could explain this, and I know how to make this. I'm gonna briefly explain it, but I can make my own. It's just, first of all, I'm way too lazy. Second of all, this is more efficient than mine that I made a while ago for a few sprites. The backpack's not opening. That's never a good sign. Oh, everything's frozen. Never a good sign. Oh boy. Alright, okay, it's still saved. Whew! Alright, but yeah, I made my own script for this right over here. It's a bit more complicated and very inefficient FPS wise. That's why I decided to change to this. But yeah, if you guys are wondering where I got it from this sprite right here. Alright, first let's explain this. This will set the size to 100. This is the rotation style. You don't have to worry about that. And this is the variables and setting everything up. Now, this is the gravity portion. Essentially, when this is up here, we're going to change the Y position always by speed Y. And if it's 0, then the Y doesn't change. If it's -1, the Y changes by -1. And then we subtract 1, -2, -3, -4, -5, -6, -7, -8, -9. And soon it's going to be a kind of a curve like that. Like so. And if you want to make the gravity weaker, which I will do, -0.5, I'm changing that to be a little weaker. There we go. You can see that little curve better. And the jump is pretty high as well. I'm going to change that. So basically what this is happening, what's happening here is that we're changing the Y value by 6, then 5.5, then 5, then 4.5, then 4, 3, 2, 0, and then back down to -6. Like so. And actually increase that to 10. That should be good. Alright, now before you guys copy any of this or make it on your own, there are some things you need to know. First of all, these purple blocks, these are called functions. If you guys look at the Patch tutorial thing, you guys are going to understand all the other stuff. But functions, you do not know what functions are most likely. So, if I say, when flag clicked, and then I say pi, and that's pi, and then this is the end, so let's do that. When flag clicked pi, what does that mean? Well, first you gotta define pi. So pi means move 10 steps and then turn 15 degrees. So basically what I'm saying is when this is clicked, I'm going to activate pi. And pi means this. So in reality, I'm just saying move 10 steps, turn 15 degrees. So if you say pi, 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 that means I'm doing this 3 times. So I have to write this down 3 times. Or, I could say pi 2 or 3. What does that mean? Well, that means when I define this, I need to say pi with an integer value of 3, or number value in this case. My bad, my cheek was a bit itchy. So with an integer value of 3, with the name of, let's say, muffin. So basically, or no, you don't put that there. When I run this, I'm gonna save this 3 value into this muffin variable name. If I say 3, 7, and say int bagel, that means I'm saving 3 to muffin and 7 to bagel. And I can use this, so I can say something like move muffin steps and turn bagel degrees left. What? Degrees? Wait. Yeah, degrees. I did it right. Oh, oops. Don't worry, it was a brain fart. Alright, basically what this means is when this is clicked, I'm gonna have my 3 value for muffin, my 7 value for bagel. So muffin means 3, so it means move 3 steps, and bagel is 7, so turn 7 degrees left. So that's basically what this means. So if I say walk direction speed, I'm putting the speed here, or direction is -90, speed is -4. So if I use direction, this is -90, this is -4, and -4. And this hexagon, as I said, was a boolean. A boolean is a true or false statement. So if we use up, so if we say touch ground, if speed y, or the velocity for y, the curve, is greater than 0, then that value or boolean will be true, so this up will be true. If it's not true, then this will be false. One more thing, if you guys are going to create your functions, you gotta add run without screen refresh. Basically, this means you run all this code without any delay between the lines. So usually for this, it's gonna say, alright, do this, then 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 this. Here it's gonna do this, just all of it instantly. So it might cause a bit more lag, but essentially you need to do that so this gets calculated better. Alright. Over here, this is our slope calculation. It calculates the slope and sees if you can climb it. Like here, I cannot climb this. It can go up a little bit, but I cannot climb the entire thing. That's because the slope is greater than 8 or -8. If I change this to 10, then I'll be able to climb this, because 10 is about that steep, 8's about that steep. So yeah, and ceiling detection is what this up means. Alright, now that you have our physics going, we're gonna add the coin aspect of it. Oh man, coins, alright. So, what are these coins gonna do? Over here, we did the coins from before in the intermediary stage, and we're going to use the same code, except we're going to do the not touching black, and I'm going to do that. So the coin spawns, but there's one problem. We can't get it. So how do we fix this? Well, it's actually impossible to fix with this code, because I'm not using this as a ground. I'm not detecting it as a ground. I'm detecting it with, or as the black color. And because that's black, it's gonna act as if that was the ground. So an easy way to fix this is by making this almost black. So let me put this all the way up and make this almost black. Almost no difference, but now it should work. That's not enough. Yeah, now it should work. And our score's right here. Alright, now if touching the character, we have to do that. Just do that real quick. Character change score by 1. And blah blah blah. If touching color black, because we don't have our walls anymore because we added gravity. There we go. Should be working now. Touching care. Oh. What in the world? I forgot to rename it. Alright, now it should be working. So our coin is moving randomly about the place. But there's one problem. What's that problem? You guys may or may not have saw it. It's where the coin is. If the coin's up here, how are you supposed to get it? It's impossible. How do we fix that? Well, you gotta limit the area of the coin spawn. So we can't make the coin spawn too high up. So nowhere above y equals, say, 100. Or maybe 150. So we gotta change this y to 150 max. 150, 150, 150, 150. Alright. And we don't want our y or our coin to be up there either. We don't want our coin to be past x equals 200. So we have to change this to 200, 200, 200, and 200. Now our coin spawning area should be very limited and should be very possible to get it from all areas. Alright, cool. Now that we have that, we need to add an enemy. Now our enemy is going to be, well, I don't want that. Our enemy is going to be kind of like an AI controlled enemy. And this enemy will try to shoot us down while we're getting our coins. Because on here, game mechanics, help instructions, user controlled sprite, a not autonomous sprite. You know what autonomous is? That's basically like AI that it works by itself. Autonomous sprites. And we're gonna change the overall impressions of the game, because if this is it's like, oh, okay, let's get the coin. Take however long we want to get our Skywars coins. That's boring. No one wants to play that. We need to add an AI. Alright, so first, how are we going to make this AI? There are many ways to get your AI to work, and you guys might have saw some ways already. And that's if, like, the AI just follows you, like, the set direction to you, this, and move 10 steps. But that's not going to work because these things are in the way. So how are we going to make an AI then? We want the AI to be jumping and following physics like this. How do we do that? Well, we're going to duplicate this and we're going to call this AI. Now our AI over here is not going to be spawned here. Well, first we're going to hide it. Let's do hide. And then we're going to show it after 5 seconds. So it's hidden. And wait 5 seconds. And it should show up now. But our AI is controlled by us, which doesn't really make it an AI, because AI needs to think for itself. So how do we go about this? First, we need to differentiate between the AI and us. Let's make this blue. Very noticeable now. Now the character should actually be blue, so because blue is usually the good guys. But yeah, let's just change that real quick. Blue, red. Oh, my bad. Red. So we're the blue guys. Now we want the AI to be chasing us. And how do we make it chase us? So we gotta get rid of this, definitely. And we'll probably need to get rid of this as well. So this AI doesn't have an AI yet, but all the physics are in for him. So if the character position is on the right of the AI, so if the X position of the character is greater than the X position of the AI should move towards the character. So if the character position, we can use this with sensing, X position of character is greater than the X position of the AI, which is here, then we're going to walk towards the AI. There we go. And if the X position is less, then we're going to go the other way. So right now it's chasing us. And we also want the AI to be a little bit slower than us. So we're going to change our speed value over here. And it's going to chase us, but very slowly, as you can see. So it gives us time to dodge it. Now, another thing we want to do is, if we pass the AI, we don't want it to follow us instantly wherever we go, because the AI can't think that quickly. We want to give it a delay. So we need to give it a 1 second delay. Or not 1 second delay between each one, but 1 second delay here should work. Oh boy. Nope, definitely should not work. And alright, I just thought about this as I went. So the delay thing. So repeat until not exposition. Exposition. No, where's not? Not exposition is that. And then we're gonna repeat it, say 10 more times. So, oh yeah, it's a spawn in. So let's just wait right here. And it's definitely not following gravity. What was that? Young man, what was that? So if I go here and then juke him out, there's that little bit of delay. So we do that same thing on this side. Except we have to use this, obviously. And we have to inverse that. So now our AI should be a little delayed. And maybe should follow the law of physics. What in the world? Alright, let me check this real quick. Oh, my bad. The delay is also affecting the physics. So we should change this, and everything should be good now. The AI is following us slowly and takes a while to register our turns. Alright, that's pretty cool. Now we want the AI to jump. How do we know when the AI should jump though? If it just approaches a wall, should it jump? Well, that's an easy AI. We want a difficult AI. We want an AI that will, jump beforehand. If I was right here, I'd have to jump from here and get on top of it. I'm not gonna stick to the wall like this and then jump. I'm gonna jump from here for maximum efficiency. You may be wondering, how in the baloney do you do that? Now we can either use a pen, or we can use a different sprite as kind of like a hitbox manager. So we're going to be using the hitbox manager for just for easiness. We're not going to use a costume though. So from this, we're going to we're going to go to the X position and Y position of the AI. So what am I doing? X position of AI and Y position of AI. So this is going to be wherever the AI is constantly. And this is going to be the left side of the AI's hitbox. So this will go from starting here, go left until it hits anything that's black. So if I make this jump down here, so I want this to start here and go left until it hits this black wall. Alright, so basically I would thinking how I should do this. Man, your tutor should really know this beforehand. We're going to move or point this direction. I believe that's -90. And with a pen, we're gonna pen down and move 10 steps. The reason why we're doing pen down is so we know where this object is located. There's 100 steps. So we know this is moving all the way left. I'm going to clear this. So yeah, this is the detection. From here, it goes all the way. And we want to stop the detection right here. How do you do that? We need a function. So left detection. I'm going to make this instantaneous as well. Or wrong thing. Left detection. Alright, cool. Now that doesn't really help us, does it? Yes, it does. We're going to do left detection. I'm going to point. I'm going to move one step. But we're going to move one step until, repeat, until touching color black. So this is going to move one step until it's touching that black color. And very laggy if I do say so myself. I think I might have just crashed Flash. Alright then, we need to go a more optimistic and less laggy way. Oh boy, it's pretty late. Oh well. What is happening? Oh, there's your worst nightmare sign. Alright, we're gonna have to do this another way. So we're gonna point this in the left direction. And we're gonna create our function like before, and this function's gonna be run without screen refresh. Left detection. There we go. Left detection. Here we're going to change, or actually we don't even need to face direction. We'll just change the x position. Change x by negative. We don't need to round too much. We just need to get it approximately right because we want to save our CPU. Change x by negative till, or -5 until we touch that black wall. This may still be mega laggy. Oh boy, yep. Not good. Not good. Alright guys, well you guys get the basic idea. You guys get the basic idea of what to do. If you want to do that, I'll do it the other way now. I know, I'm such an amazing tutor. If I find an easier, more efficient way, I'll show it to you in the next episode. And we broke Scratch. Congratulations, Ray. You did it. Alright, it's loading. I don't know why it's lagging so much. Should definitely not be laggy. Alright, so the other way to do this, which is 14 trillion times simpler, but the same concept, is if I do this. Then this is gonna be about, or I have to increase this by a lot. Maybe by, let's do 35. Let's say there's gonna be 35 left of this AI. What is wrong with Flash? And if this is always 35 left of the AI, and it's right here, and if this is touching black, well, that means the AI should jump. So, if touching color black, then we need to broadcast a new event that we haven't used before. Left jump activator. Or no, just jump activator in general. So when the AI gets this message that says you should jump, so when I receive jump, then what do? You jump. And you gotta do if falling is less than 3, so there's an infinity jump. And booyakasha. I'm gonna exit that page because all the scripts are probably gonna make it a bit more laggy. Jump. You did not even try to jump. What? Are you working? I'm gonna make this a very vibrant color to see. Oh, of course now you want to jump. Well, that makes sense because if it's not there, it can't jump, you know? If I do this, but I hide this, it should still work. Alright, so I'm gonna go here real quick. Yeah, I should be there. Alright, that was nice jump. Nice infinity jump. Stop jumping like that. No, bad boy. It's jumping in midair. It's not normal. Not normal, I say. So how do we fix that? We gotta get the is falling. There we go. And it should be working now. I gotta get the AI to spawn in the middle too. And jump. Oh yes, that was literally amazing. If I make it come over here, jump, yes, that was amazing. Now the AI won't jump up there because if it's sensing right here, it can't sense up there. If you guys want to do that, you guys would have to extend this line like so. Now the only problem with this is if it's right here and it detects that, or if there's a platform here and there's one close to that, and you just want it to fall, then it's gonna jump. It's the only problem with the AI. Other than that, the jumping mechanics are pretty solid. Alright, so I want you to come down here, or go this way, and then jump. Alright, cool. Now come back over here. No. Come back here. Jump. Jump. Oh boy. You guys are wondering why that's happening. That's because the AI, it's right here, but it's not detecting the fact that it should jump. And if you're wondering what I mean by that, well, it's actually pretty simple. So, because it's right here, or like right here, this jump is right here. And there's no black right there. So it's just waiting until it touches this or the bottom, and then it jumps. So if I do this, that means there's a triangle. If it's in that triangle, it will jump. If it's in this triangle, it will jump. That should fix most of the problems we have so far. And jump. Oh, no, it did not jump. That's okay. We're still in the troubleshooting stages of this. And because the AI is obviously encoded in black, it's not working out too terrifically. Come on, jump. You got this. And it's not tall enough. That makes a lot more sense. That is nowhere near tall enough. What, Ray, what are you doing, young man? That should be way good. And this vertice should be touching the ball. Alright, that is good. Now we don't want it to show, obviously, because that would make everything catastrophic. And it should be jumping now. And the only problem now is that this triangle is touching this to make this shorter. Still touching. Still touch. What is wrong with the AI? Because when it jumps up here for the first time, then it feels the need to jump again because it's sensing that little thing. It's a bug. Bug indeed. Oh my gosh. Stop jumping. Young man. Stop jumping. Oh, I know why it's jumping. This is too close. There we go. Yes. Nice. Alright, we got the AI to work. Pretty cool. Alright. Now we should probably change the color of the AI, this part, to something not black. Okay, that's way too much contrast. Just red. Alright. Cool, now we have to add this detection to the right side. How do we do that? Simple. And align. There we go. And we gotta change this to positive, and boom! We got a working AI. And spawn in anytime. And if we make it fall down here, it should jump up. Yes! It's working. And it should not jump there because that triangle's gap is not big enough. It is jumping there though, which is a problem. It's okay. But we got the AI to jump. It's all that matters. Now we need the collision detection for the AI. So if the character touches the AI, so forever, if touching the AI, then you gotta do something. So we're gonna stop all the code, but before that happens, we're gonna say, or the wrong section, say your score was, and then we gotta use the join. Let me just copy this, paste it there. Your score was, and then we're gonna hit the score. Wait a minute. Wait a minute. Alright, okay. I don't know if that worked. But let's die on purpose. Where's the AI? No, don't jump over me. Oh my gosh. It's because I have black on me. Not very favorable. There we go. Our score was 0. Oh yeah, we need to recreate the score variable. Oh no, there it is. Alright, it should be working now. Can I reach that? No, I cannot. Yes, I can. Why was my score 0? Character. Oh, these variables are independent. That is not good. I need to delete this. Make a new variable called score. And that should do it. Score. And boom! We have our game. There's the AI. Your score was 4. Yay. And everything stops. Cool. We have our game. Alright, the next episode, in the next tutorial, we're going to be doing the expert difficulty. Now, I'm not going to make it right now because it's 10:51 p.m., but in the expert difficulty, we're going to have a lot of new things. It's going to be a really long video. So we're going to add scrolling platformers. So when your character is aligned to the middle of the screen and the whole screen moves, kind of like Mario. Images. Super Mario. Why are there no pictures for Mario Bros? So in this game, Mario is aligned to this X position. He does not move from this X position, but the screen instead moves for him, which gives him the illusion that he's moving. We're going to create that. We're also going to create items and things that you can pick up, such as a jetpack or just more speed in general. We're going to use the more difficult AI, and most importantly, we're going to do everything on this except for obviously the ones that don't require Scratch or require something else other than Scratch. Those things include things like, well, we might do sound actually. I don't know about sound. Code organization. I don't know if we're gonna do this. Well, I mean, coding is efficient. Yeah, we get that it's efficient, but I don't know if we're gonna make it efficient. We're definitely not gonna do documentation. We might do end of game options. And we might do gameplay stops, but I don't really see a reason to have a gameplay stop. But yeah, okay. So next episode we're just gonna be going over a lot of stuff. And I know that this video's almost 40 minutes long. But yeah, I hope you enjoyed this video, and until next time, don't forget to turn off your sticky keys.